Hello and welcome back to another video. So without further ado, let's do it. So today's video is nothing special really. We're just going to be focusing on using modern C++ with modern CMake. So it's going to be AniPrint. So we're just going to make a nicer version of printing things, so we can print stuff using this. So let's create a CMake file real quickly, because I'll be demonstrating how to actually use modern CMake for just basic things, getting started quickly. Well, I have no kids, so CMake minimum required. For our case, we're going to do 4.2.1. Then we're going to be adding a target, so it will be an executable, and that will be for our case a.out. You can use whatever you want, like something like AniPrint maybe, but I prefer using a.out, so I'll be using that. Then we define a project, because project is important. Last time I forgot how to add this. So the project is going to be, let's call it AniPrint, why not? And then after AniPrint, what we will have is the version name, so the version number, so version, and that is going to be 0.1.0. It's kind of a main version. Oh, and I forgot to add a version keyword over here, so let's do that. And after that version, we have 0.1.1. We're going to specify languages that we're using, and that is going to be CXX because we're using C++, and description is going to be animated print. Yeah, animated print. It's a good description, I guess. Or how about printing text with an animation? Okay, yeah, that's fine. After that, we're going to specify some properties and some compiler definitions. Well, not definitions, but compiler. What's that? Compiler. Okay, so compiler flags actually. So for that, we need to define target compile features, and we're going to set our a.out private, and this is going to be standard CXX standard 26. We're going to be using modern C++, so we will use C++ standard 26, which is why CXX standard 26, because C++ is not always usable, so we will be using CXX as the thing. Next, we need to turn off some extensions, because by default on Linux you have the GNU extensions, the GNU C and C++ extensions that add some things. So we are not going to be using those C and C++ extensions. We will be disabling that. So to disable it, we will do target compile target properties. Yeah, set target properties, and that will be a.out, and it will be properties, and we are going to disable CXX extensions So to turn it off, we will do CXX extensions off and C extensions to off. Although we are not using C, we can remove it, but if you're using C, you can turn that on if it's applicable to you. And then, since we have it, we are going to add some compile options, and for that we're going to use some generator expressions. So that will be set, well, no, add target compile options. Yeah, so a.out, and that will be of private, and we are going to be adding a compiler, or adding an expression actually. So this will be checking for the compiler ID. We are going to conditionally set some flags. So if this is if CXX compiler ID is Clang, then we are going to do -w everything -w no -c++98 hyphen compat. That will be compat. For we're just setting that no C++98 compatibility because the Clang -w everything actually enables all of the warning flags, and that's kind of a problem because it will actually emit so many warnings about C++98 compatibility, because some things like auto, for example, auto x equals to 90, now C++ will deduce it as int x equal 90, and it's not C++98 compatible, so we are not going to, so we want to, well, we don't really care about that, so we can just turn it off. And some more good stuff that C++98 doesn't have, so we'll just do that. We'll turn it off. We don't want to limit ourselves. We will be using modern C++. We don't care about the old stuff. So this will be C++98 compat pedantic. This means that all of the rule breaks that all of the rules that we are breaking in the modern C++, that well, the modern syntaxes of sorts like the auto keyword and things, these are the rule breakers in C++98, because C++98 didn't have all of this. So if you want to maintain compatibility, you can just remove all of this. You don't want this, but I will be keeping this. I'll be adding these flags because I don't want C++98 compatibility. Now another thing that I'll be doing is I will be setting something which will make our compiler super annoying, basically won't allow us to compile our program whatsoever because of some warnings. So we're making sure we are 100% safe. CXX compiler ID, if the C++ compiler ID is either GNU or GCC, or GNU, or is it Clang, we will turn -w equals to error. So -w error, and that will set everything as errors for us. And since I will be using Clang for this because of one specific flag, which is -w everything, I won't be mentioning anything else right now. Yeah, I won't be mentioning anything else. So with that, we have defined some compile options, we have defined some target properties and some compile features, which is the C++ standard of 26 and C++ extensions as off, and some compiler options. Now we need to set our targets for the executable. So the way to do it is target compile target sources, because we want to define some sources for it, and that will be a.out, since our executable is a.out, and this will be public, and we will use source/main.cpp, and we're going to create it. So source.main.cpp, or sorry, source.main.cpp. We have it. That's good. And then what we are going to do is we are going to select a kit, and that will put CMake on this standby mode. So let's see if everything is correct. Select a kit. I'll do Clang 21, and great, everything works. Let's compile our program. Let's compile it into main, and does it compile? As you can see, oh, okay, that doesn't work. We need to go to bash, and what we'll do is run build/a.out, and then we're going to do echo $1 yeah, as you can see, we have this it returns 0, because int main by default actually does 0, so it's the same as return 0, which is why it doesn't complain. It's a C++ feature. It's a C++ feature. So we are good with that. Very good with that. Just to be sure, we can do -1, and it will round up. What you will see is, if we run it, as you can see, we have a red mark. That means it failed. Great. And the green is always, yeah. Now just to check if we are on C++ standard 26 with all of this CMake stuff. So what we'll do is #include print header, and what we'll do is std print ln, print ln std out, because we are writing to the standard output. And after that, what we will do is we will print C++ -std equal to, and then we're going to print out the C++ version code, which represents a standard, and for C++ 26 that's 2024-00. Great. It's the C++ 2D, which you can actually see if you go to the compile commands JSON. And if you're wondering how to export the compile commands JSON, I have a video on it where I have shown how to get all of this, so you can check that out. As you can see, the compat pedantics, the -w error, everything is there. It's all due to the generator expressions, and our C++ versions and everything is correct, and it just looks so much better. Great. So what we can do is we can get started on our cooler version of the animation printer, well, printer animation. So what we'll do is we will make a int function, well, integer type function. So the return type is going to be an integer, and it will be print AniPrint, well, AniPrint okay, so let me do it. Okay, so AniPrint, and it is going to take a string, so we are going to pass in a string to it. So it will take a standard string output, a standard string input str, and we need to include it. Okay, hash include string. We got the string. Great. Oh, why are you complaining? No previous prototype for function AniPrint. So we need to declare a prototype, correct? Yeah. You might be wondering, why do we need it specifically? You can actually remove this. C++ doesn't require you to have a name for it. For a prototype, you just need a type for it. The reason is because we have enabled the -w everything, and there is a warning about prototypes, that there are no previous prototypes, so it expects you have a header file for most things. But since we don't have a header file for it, we're just going to do actually we can disable it with -w missing prototypes. So -w no missing prototypes, -w no missing prototypes, and should that, and does that work? Does that work? -w no missing prototypes, does it work? And it does work, and it's not even throwing an error, but it will complain about unused parameter, which we care about. Actually, I'm fine with it complaining about it, so I'll just keep it like this. Now what we'll do is input string. So for input string, well, for const char in input string, so we are using a range-based for loop for this. For const char in input string expected, oh, we need to define something, chr, because it's yeah, chr. This is going to be chr, yep. And then what we will do is std println, and this is going to take in the file to where we will be writing it. So we're writing it to the standard output, and it's going to take in the string, so we will pass it. So instead of println, we can just do std print for char in input string. We can just do it. Sorry for that. So standard output, and we have that, and we're just going to print out the cchar. And why is it complaining? Oh, we need to return a value. return 0. Should that fix it? Oh, and we need to give it AniPrint. Let's see what does it print, and as you can see, it works great. And we can also do stdprint ln, and it will just, yeah, and it will work great. Nice. Now this is very boring. We need to glam it up to make it more nice and look cool. We can do is for char. We are going to start the character at for const or for size t. I prefer using size t. You can, well, it's not going to be size t, it's going to be char, because type mismatch is going to cause a warning for us. For C char, that will take the position of CHR. So that means that whatever thing is inside CHR, so if it's A, it's going to start from position A and then increment all the way. Actually, we're going to start from 0 because we are going to be iterating to that position specifically. So if CHR is less than or equal to the C char, then what we will do is we will increment C char, and then we are going to print the C char. So let's do that, and as you can see, that is great. Yeah, that's great. So it starts from C char and then it prints the character all the way. Yep. Or we can do something else. What we can do is essentially to check if it's correct, what we'll do, char C char equals to 127. And that's going to do a lot of things for us. Yeah, it works fine. Now the reason why it's having a buggy input is for one of the many things we have, and that is we forgot this line. And the other thing is that for the characters in 0 to 31, which is total of 32, because 1 to 32 is 32, so 0 to 31 is 32. Yeah, so for all of this we don't have it and we want it. So the way to do is we're going to check with an if statement. If if the C char is less than if C char is less than or equal to 31, we are going to skip it. Not skip it, but you will see it in a moment what we are trying to do. As you can see, it's a pretty messed up output. It's a highly messed up output, which is not what we want. So if it's within 0 to 31, what we will do is we are going to continue. We are not going to print it. Oh, and we need to check for one more thing, and that is if C sharp and then C sharp not equal to C sharp. Yes, that is important, which you'll see in a moment, because when we do this /t, it will be printing /t just fine. But if we remove this condition, it's actually going to cause a lot of issues for us, because it can actually skip over the /t, which is the tab, which is the is it horizontal or vertical? I forgot, but which will skip over the horizontal or vertical tab, whatever that is, which is not what we want. So we want to keep it. So we are making sure that the characters are in this position, or else it is a problem. Sorry for that. And as you can see, it works great. Now you might be asking me, like, look, hey, it's broken, there's this rubbish output. And that's not a problem, because we'll be fixing it soon. What we'll do is print it, and then what we're going to do is stdff flush. We want immediate flushing of it. So std flush std standard out, so it will flush the standard output the moment it gets a character. Just to be safe, we can do it. This just means output as characters, which we are doing. And as you can see, it works the same. Now the main condition. Another condition is if C char is equal to C char, then what we will do is we are going to break, and that will break out of the program. Yes. And if not, we will keep continuing. So we will just continue, and that will be std flush, and we're going to be looking for the backspace, and usually we have some things. So the std print, and we do std out and std /b. It will just keep deleting characters, and if I comment it out, you will see that we get nothing at all whatsoever for some reason. So this is what to do, and with that you will see that we get the correct output. We get a correct output. We have the checks. But you might be asking, hey, we just reinvented the wheel of printing. We used a print function to print in a complicated way. We don't have an animation. Well, now this is where it gets fun, because we have a character. So we are basically going through it character by character, and we have an input string. We can do some fun things with it. So before we break out of it, we can just wait. So we will do something neat, and that is standard this thread sleep for, and that will be 100 milliseconds, and we will do is using namespace std chrono literals, and let's include chrono because we need it. Why is chrono not needed? But okay. We have included chrono, and as you can see, it's doing something neat for us, which is this. But it is painfully slow, so I guess 10 ms is good. Yeah, now you have that hacker type thing, you know, hacker animation where it does cool shit. Here it is. Cool things right for you. You can just do whatever you want with it. Let's do 50 milliseconds because 10 milliseconds is too fast. It's basically looking for characters and matching it and then printing it. So it has the time delay of that character. You can actually type, for a more fun way, you can actually typecast it into milliseconds for it. So what I will do is, over here I'm going to typecast C char into an int, and that's kind of a sad. That's sad. Cd this std chrono as std chrono milliseconds, and that should do it. Now what you will see is that it is in variable length or variable wait times. So if I just do something like I don't know, character if I just do something space from here, what you can see plus, yeah, from what you can see is that we will get some variable time, which you can see from here. So this gives you the illusion of the waiting times, you know, that it can be different. So you can do just that, or if you just don't want to, you can do this also and it will work. And what we can actually do is milliseconds milliseconds. Yes, using namespace. Yeah, we're just going to be using standard kernel. Or what we can do is actually using milliseconds, using ms equal to std kernel milliseconds unknown type alias ms, and we can just do ms, and yes, that also works. You can do that also. Now to actually typecast with a modern C++, you just need to use static cast to this, static cast it, and that's what we want. The milliseconds with the static cast of int, we are converting it to int. So a can be broken down into exactly 65, right? In hexadecimal that's 41, but it's 65 in decimal, and in octal it's 101. What a nice number. Great. So if we just compile it and run it, as you can see, it has the same illusion and it just looks great. So as you can see, it has that, and you will get hello world from Nemadian C++ 26. Now you can use modules, but since modules are a bit unstable and still doesn't have that much great of an implementation, I'm not using it, but feel free to use it. That's totally up to you. You can actually speed it up with we can just do ns, and this will be nanoseconds ns, and what you will do is multiplied by 10. Still too fast. 100. Still too fast. So what we will do is 1 to the power of 10 from the we can static cast it, I guess. Static cast it is. We can just static cast it. Static cast with int, and it'll work. Maybe exponent of 100, 1000. Oh, that's a lot. 10 to the power of 100 should suffice. And it's okay. It's a bad idea. Into 150, maybe 1500, 1500s. We are getting closer. Very nice. So if you have something like 127 into 1500, that's this much, into seconds. Actually, we just convert it to seconds. Nanoseconds to seconds. Wait, how do you do it? Second ns. Yeah, we have 190 milliseconds squared, nanoseconds into seconds. Right. For 1700, that's 215 milliseconds, which is also not bad. So let's run it again, and 7, maybe 800 will do it. That's still too large. 2000, we are getting closer. 27,000. Actually, let's go to the power of 8. 1000. Closer. 100. This is extremely fast. So how about 1300? Is that good? I think keeping it in millisecond was good. Milliseconds. Yeah, millisecond was good. But yeah, as you can see, you have variable length in this. So, or since it's a bit painfully slow, we can divide it with 0.5, maybe 1.5, and yes, that's much faster. So yeah, this is just printing with extra steps, and to make it a bit cool, I guess it's a bit cooler. You can definitely tell it's fun. You can always do it. Yeah. Hello from modern C++. It's taking some time. This is painfully slow. Yeah, this is painfully slow, so we'll add it up a bit. Yeah, this is good. Two 2.5 is the best in my opinion. Yep, this is the best. And now this is how we do it. Now the problem might be that you have something like you know, you don't want to always just write this, recompile it. It's annoying, right? So we can do something simpler. What we'll do is we are going to create create an argument taking interface. So we're going to create an interface that takes in arguments. So our program will accept arguments, and using that we can just pass it to AniPrint function. The way you do this is with int argc and char star argv. Char start, well, pointer argv. So first things first, so we're going to check if argc is less than 2. So if argc is less than 2, we'll do a std print ln to a standard error that hey, something's wrong. So the output will be that this program is invalid. Please pass in a string. Please pass in a string using /n/n. Let's pass in a string using another thing you can do is actually we're going to use a row string, and from a row string I can do this. Please pass in a string using using from line 1, line 2. That way we can actually supply multiple lines of text and it will work. Or how about this? Yeah. Actually, do we need to? Please pass in at least one string. Okay. So what we can do, and then what you will do for size t args iter, which starts at 1, because we are going to skip over the program because arg C at 1, argc with value 1, rc0 always equals to program name. So we can just safely skip over it. Oh, sorry. argc at 1 is always the program name. So which is why we're doing this check. And with that, what we can do is well, args iter size the args iterator then what? Let me think. So for args iterator less than argc, because we are starting at 1, so we cannot do equal to for this. And then what we're going to do is plus plus args iterator. That was the issue. Oh, what did you size t for this? Size t. Oh, main only takes in integers. So let's convert it to size t, because I always prefer using size t. You can use whatever you want. And then we're going to create a string, right? So what we're going to do is get a string argument, and then we're going to null set it, and after that we're going to set argument equals to argv at the position of args iterator. Okay, so this is just unsafe buffer access pass. Unsafe buffer usage. That's interesting. Pass dash of safe. Why not? What? Oh, that was very weird. This is probably a C Clang flag. So let me see. Where is there? There's still another error, but I do not see it. argv is unsafe pointer used for buffer access. Buffer usage. So maybe this. argv is unsafe. You don't know what you're talking about, Clang. Can it be const? Yeah, right. You don't know what you're talking about. I don't care. I'll just unsafe buffer usage. I'm just going to disable this Oh, come on. Why can I not copy? Does that do it? Yep, I just fixed it. I don't care. Argument equal argv point or args iterator. Okay, and with that we'll just pass in that argument to yeah, we're just going to plus equal it. Yeah, so plus equal it for input string. So print AniPrint, and then we're going to pass in the argument, and that will be it, I guess. So with it, hello, does it work? Let's see. Hello. How about hello world? It should treat it as different. Yes, it works. Hello world. Okay, and with something like, if we do it like this, now what does the result produce? Hello world. It should be just one string if I'm not wrong. Hello world. Yes, it's one string. You can do it like that. Great. What about numbers? 10. That's great. Symbols. Maybe 90. And it fails. Well, that's going to be a different topic. And to actually add more options to AniPrint in terms of argument, where you want to handle arguments, I will be making a video on it soon, so you can look forward to it. But yeah, other than that, this is all we have. This is a demonstration of modern C++. And C++26 and all of the cool and neat features such as standard print that you might want to use, because we don't need to include a different library, though libfmt is much more versatile than standard print, which you might encounter because libfmt has a lot of features. But yeah, with that, this is the end of the video. I will see you in the next video, hopefully soon, because I'm usually busy. So yeah, but hey, that's a wrap. And if you like this video, please make sure to give it a like. And if you want to be updated on the latest videos, you can subscribe. It's free. I'm not forcing you to. It's up to you to subscribe or like. If you find it helpful and want somebody else to learn, maybe you can share it. But yeah, I will see you in the next one about argument parsing. So see you next time. Bye.